Hello, hi everyone. Thanks for attending my talk. Today I'm going to talk about the AGL Compositor, more specifically about screen sharing in the AGL Compositor. So before going over that, for those who don't know me, my name is Marius Vlad. I'm part of the graphics team at Collabora. I'm the Weston release manager, and I'm the AGL AMM Compositor maintainer. So besides going over the screen sharing, mirroring, and casting in the AGL Compositor, I have a bunch of slides going through the Weston 15 features in terms of preview. And I have a slide going through the, the changes that made it through since the previous AGL AMM. So what's screen sharing, what's mirroring, what's casting? Well, basically, they kind of mean the same thing. They have different scopes, obviously. They use different technologies to achieve their goal. But in essence, basically, they duplicate content from one output to another output. This to another output can be a local output, the way that I'm doing it right now, or it can be like a remote output to a different device. You can do that with individual windows. You can do that with parts of the output, or just like the entire output as a whole. But it's not obvious when it's casting, when it's mirroring, or it's screen sharing. So here's an example of that. If we are to look on how the clients connect or how clients display incoming content, we have like two basic categories here. We can use like RDP and VNC backends or the screen share module, or we can use like remoting and PipeWire plugins or the PipeWire backend. The last one is more closely to mirroring, where the first one is more closely to screen sharing. All of these backends, plugins, and modules are exposed by libweston, which is the library that the AGL Compositor is built on top. So in terms of backends, we have RDP, which is like an older backend that we have been using. VNC and PipeWire has been added fairly recently. The backends themselves make use of the libraries to actually create the buffers, hand those buffers to the compositor. The compositor on the repaint part, it will use those buffers to draw content into. But the underlying libraries are the ones that use the protocols to actually send data over to a remote client, basically. So in terms of modules and plugins, like I previously said, the remoting and the PipeWire plugin are more closely to casting or mirroring. And the screen share module, is more closely to screen sharing. The plugins themselves, like the remoting plugin, makes use of the GStreamer pipeline to actually create some DMA buffs and passes that to the compositor. PipeWire plugin uses the PipeWire API. And the screen share module, it requires to create a different compositor instance with a different backend and a different shell entirely. Now, all of these plugins and modules are being phased out. I've actually removed the screen share plugin in like Weston 15, and the similar thing will happen with the remoting and the PipeWire plugin. Screen sharing on its own is largely inefficient because it just copies the entire output, sends it over to a different compositor instance where you connect with the client to it. The remoting plugin hasn't seen any changes since 2018. I had a look at it and trying to see if I can improve it, but there isn't a lot of traction into doing that. And the PipeWire plugin basically has a PipeWire backend, or where all the development takes place. So in the end, we're just going to have the backends. How do I actually do screen sharing? Well, we make use of the PipeWire backend. We used to do that with the remoting plugin. And similarly to the remoting plugin, we make use of a GStreamer pipeline. Basically, we take the PipeWire node, and yeah, we send it with this like GStreamer pipeline that it's being displayed here. I have this diagram. This diagram basically shows that we have two backends, each creating two outputs. One of these outputs is the embedded display panel, and the other one is output created by the PipeWire backend. Now, how about mirroring or casting? Before going into that, just a simple, a bit of context. All of these backends, the RDP, VNC, and the PipeWire backends, are what we consider secondary backends, and these create what we call virtual outputs. We also have, obviously, the DRM backend, which uses like the native DRM API, which creates native outputs. A while ago in Weston 13, we added the ability to load all these backends simultaneously at the same time. And naturally, out of that, this mirroring or the casting functionality arose for free, basically. So normally when you start the compositor with two backends, each of these backends will create an output. And there is a policy inside of the AGL Compositor and the Weston Compositor, which places any new output in the system to the right of the previous output being created. That's how it's shown here on the left, where you have two outputs, one created by the native backend and one by the virtual, by the PipeWire backend with a virtual output. Now, if we are to avoid doing that entirely and just use just a single point of reference, we can basically superimpose or overlap one output on top of each other, giving us access to this mirroring functionality. If you were to combine this with a GStreamer pipeline and stream the PipeWire output, you basically get mirroring as is. How do we configure that in Weston? Well, we introduced this mirror of key, and this mirror of key basically takes a native output, like HDMI A1 or ADP1. And yeah, obviously it tries to, create a mirror output of that. Now, we don't really have this in the AGL Compositor, but adding this functionality is rather trivial. We can code the same keyword, or we can use a different keyword if you would like to. Besides, well, a common feature when screen sharing an output, you also like to give the person that you're screen sharing input control. And naturally, with the VNC and the PipeWire VNC and the RDP backends, you have that already because they also carry input. But with PipeWire, we don't really have that option. And this is more like a custom solution for users which don't want to use RDP, VNC. Maybe they have a different compression algorithm, or maybe they want to actually control the entire pipeline. They might be able to, well, use something called lib emulated input. And I have this really ugly diagram to show how would this work. So this part with the client, that basically is what happens over the network. That's the remote side. The remote side has to have a way to get the input and send that input to a distinct process. This distinct process lives on the same host as the compositor lives. It gets that input from over the network and uses this lib emulated client implementation to inject input events back into the compositor. Basically, what we're missing from this picture from the compositor side is to have an implementation for a lib EI server. And yeah, that's kind of it about screen sharing. In terms of what I've been doing since the previous AMM, so we used to have this AGL Shell desktop private extension, which we were using for window management, and we basically removed that out in favor of using gRPC, which is a gRPC proxy server, which lies between the client and the compositor. On the compositor side, it uses a Weston protocol extension. On the client side, it uses the gRPC API. Like I've said, we removed the remoting plugin, and instead we used the PipeWire backend to perform screen sharing. And with that, we also had to add this ability to load multiple backends at the same time. Obviously, there were bugs involved, and but this is just more in terms of features and removals. Weston 15 preview. There's a lot of updates here. This is just names a few that I believe they're interesting. In terms of HDR, there's a bunch of protocols. One of them is the color management protocol. Last time, Weston 14 basically added update for color management protocol, but the protocol itself wasn't upstream. Now that is upstream. It also received an update, and we also did an update for that. We are adding an implementation for our color representation protocol, which is a protocol required to do HDR video playback, YUV to RGB. Without this protocol, video playback wouldn't really work. And we have now in the works, together with the kernel folks, basically, which are working on the kernel API, as opposed to using the GPU, whenever you're going to have SDR to HDR or any kind of color conversion or color transformations, we would use the GPU to actually do those color conversion. This is an alternative of actually using the display unit rather than using the GPU to do all of those things. So vendors like AMD, Intel, AMD is actually driving the kernel API on this front, but it's still not there. Another feature is this Lua shell. So I have some dedicated slides for this, but the idea is that you would use the Lua scripting language to create the UI rather than using C and libweston. We are adding experimental support for the Vulkan renderer, and together with that, we're going to have some simple clients. Another interesting feature is this EGL robust context EGL extension. So whenever the GPU encounters an error, it will emit a GPU fault. With this, we are able to trap and handle this error. What this means is that the compositor can reinitialize the GL renderer without actually be taken off or without actually being abrupted, terminated. In the same time, obviously, the clients that are running on top of the compositor would also be alive. We have also added some filtering debug scopes. These debug scopes are a way to look inside of the compositor, inside of the compositor internals, but this would also expose some sensitive information, and this is a way to, limit that. You are able to say which debug scopes are advertised to clients. If you have multiple keyboards connected at the same time, using different key maps, different language key maps, we are now able to switch on the fly between those with the help of udev config, which basically maps the key layout, the keyboard with the key map, with the key layout. And finally, we've added variable refresh rate. This is experimental. Mostly targets games, but I also can see this going through like power saving or power saving management. Together with this VRR, there's something called QMS, quick media switching. So sort of similar how the color representation protocol looks like. We can look at the video content, we can look at the video frame rate, and we could try to match that frame rate to what the sync, the display basically gives us. So if you have like 24 frame rate video, this will try to basically do that. Or if you have 30 frame rates, it will try to do that. That sort of depends, and also needs to have hardware on the display side. And yeah, regarding Lua shell, so the whole idea with Lua shell is that people usually have different kind of requirements. They have different kind of needs. So rather than just using libweston and C to actually create their own shells, this is a way of using the Lua scripting language. One issue that we would probably have if we were to go into this direction is that we need to have a way to provide the same kind of window management functionality that we have with gRPC proxy, basically. And I had a quick look at this. Apparently, there are folks which are using Lua or actually are providing an implementation in Lua for gRPC, basically, and that's a way of looking at it. Another way, although I kind of see this going side by side, it would be to actually use a Unix pipe and talk directly with the shell. I believe this goes a bit more generic in terms of like how IVI shell and Wayland IVI extension basically worked. If you would like to gain more introspection capabilities, or would like to do a lot of debugging, or obviously window management as well, basically using this pipeline. How would this work? Well, you start the compositor with the Lua shell and you give it the script. Basically, there's this dictionary table. The data structures in Lua are basically all tables. There's an initialization function where you basically create all the main logic. You have some handlers for the callbacks for different window states. Whenever a new surface is being created, whenever destroyed, set a different state. We will provide, there's an example, basically, a tiling window manager, basically written in Lua as an example, which we used as basically as a test bed to make sure we have all the functionality that we need. And yeah, basically this will lower the maintenance quite a lot, because you're just going to use stock Weston. And I think that's what I had. Thanks. Thank you. Questions?
I'm Jacek Gerecko from Intel. I'm just curious about this functionality of restarting after GPU failure. So do you mean some self-test failing or startup test failing?
No, this is
during the runtime?
The driver itself. Basically, if it cannot compile a center shader or something like that, although you have, like AGL provides an API that will give you this, you might be able to eventually get to the GPU. The GPU encounters a driver failure, and it takes down all your system, basically, all the applications. And basically that can be propagated to upper stacks, and we can handle that with that AGL extension. Obviously, the driver needs to do that GPU fault. Most of the drivers, from what I've seen, do that. Intel, AMD, NXP, VeriSilicon, Vivanta basically do that. You also need to have user space support for that, because that AGL implementation needs to have it. And we also need to be able to act upon. And what we do in the compositor, basically, we just reinitialize the whole GL renderer, basically. If we have like a flip in between, like a buffer flip in between, we have to discard that out and just like restart from the beginning. Like it's a new session. The whole idea is that you do not take down the compositor, and that's like really important. If you have something displayed on the screen, it might be like a short blip, like a short blank, but then you can get back your UI basically, and that's really cool.
When drivers and hardware supporting restarting at this level, then you can also react to that properly. Okay, and does it support also switching between two virtual machines? If so, one is you have parallel execution or parallel.
I don't really know. No, I don't.
Thank you.
Sure.
Thank you for your presentation. So in current SODEP development, it uses a Wayland kiosk shell to manage the jest VM frame buffer visibility. But it's so low capability for the window management. Past year, we can use Wayland AMM extension, but this extension is not active for development. So Lua shell is possible to use an alternative solution for the AMM extension. Is it?
That's exactly the whole idea. So kiosk shell was designed to be as simple as possible without any kind of protocol private extension. Desktop shell has a desktop client, and theirs has a protocol inside, together with it to talk to each other. Kiosk shell doesn't have that. The whole idea is to be as simple as possible. With the Lua shell, you write. Basically, you can take what we provide as an example and adapt to what you need. So window management functionality, you can use those Unix pipelines to act upon them. So you can like send some commands over that pipeline. You like to position windows, you like to bring them forth back to a different output and whatnot, basically. Yeah, that's the whole idea to use that.
It's good information for us. Thank you so much.
Yeah, sure.
Anybody else?
Yeah, thank you.